Hello everyone, it's Mrs. Walsh and I am recording for you Lesson 3 from Unit 7, which is a few special cases for compound inequalities. What I would suggest is you make sure you get out the notes sheet. We had put the notes sheet together for Lessons 2 and 3, and I suggest you get that out and continue along taking notes. And the great thing about a recording is you can pause it at any time, go back and listen, and even if you want to pause it to try to solve the problem on your own and then see if you solved it right, that might be helpful as well. So here we go. We are going to talk about a few examples that we consider special cases. All right. And versus or. We really need to talk, and we discussed this yesterday, and I'm sure everyone in Ms. Scabus's class discussed as well, that and is really more like the overlap. It has to be something that meets all of the criteria, whereas or was more of a union. It is the combination of everything. So whereas and is exclusive, it has to be both. It must be both. For or, it can be either or both. So let's see how this comes into play with some special kinds of compound inequalities. This is going to be a little bit of a review here. If we are given the graph of a compound inequality here, how do we write the compound inequality? And in this case, we can see that if we wanted to write it, let's start with interval notation, that we could see that we've got a -3 here. It's clearly running from -3 to 5. And so now we just have to see what kinds of end kinds of symbols do we want. And since it is including -3, we're going to put a bracket. And since it is not including, it's excluding 5, we're going to put a parenthesis. And if we wanted to put this in set builder notation, we would write it as the set of all x's such that -3 is less than or equal to x, which is less than 5. And we went over that yesterday, and that's not a particularly special case. Now, what you do notice on this one is what kind of compound inequality is this? This was really an and, right? We could have written this as two compound inequalities. It'd be -3 is less than or equal to x, and x is less than 5. But if we now look at this one, this had the characteristics of an or kind of compound inequality. It wasn't contiguous. It has two different scenarios that count. So with one of them, we can see that as long as you're less than -3, you're okay. So the way we do that in interval notation, if we're going this way, there's a negative infinity down here, and there's positive infinity up here, right? So we would do this in interval notation, -infinity to 3, and we have to use the parenthesis again because it's not including that 3. And then up here, we can use a bracket because we're including the 0, and we're going up to infinity. And I think you remembered that when we're doing an or, when we're saying, yeah, it's a combination. It can be this part or it can be that part. When we're doing interval notation, we don't write the word or. We use the symbol for union. So we put a big old U. And if we want to do this in set builder notation, we would do the set of all x's such that x is less than -3. And here we can use or x is greater than or equal to 0. Here's another one. It's very similar to the last example. We've got -infinity down here. We got positive infinity up here. This is clearly an or scenario. So for this part of the inequality graph, we would go from -infinity to 1. And then we would combine that with the union of that and 3, which we need a bracket because it includes 3 up to infinity. And of course, we never have a bracket with infinity because infinity isn't really a number, right? It's a concept. Okay, and putting this in set builder to set of all x's such that, sorry, my pen is malfunctioning, such that x is less than 1 or x is greater than or equal to 3. Now, let's start talking about some stuff that's more interesting. What if I said to you, I want you to graph the compound inequality where x is greater than 3 and x is greater than 6? Well, in this case, I can't really see a way to put these together into the kind of compound inequality statements we had where it was like 2 is less than x, which is less than 4. I don't really see that because in both cases, the x is greater than a number. So the way I like to look at this is I sometimes like to draw myself a little bit of a helper graph, okay? And I have to think about what numbers makes both statements true, because remember, with and, it has to be the overlap. It has to be true in both scenarios. So if I make myself a number line here, and I can put 2, 3, 4, 5, and 6. And let me start with this one. And this x is greater than 3. Let me go ahead and do that in green, okay? Let me do this one in green. And we know how to graph, and I'm just going to do it above the number line because it's just kind of helping me see this situation. So I would do an open circle because I can't include 3, and I would go that way. And now if I'm going to look at x is greater than 6, maybe I'll do that one in purple. So this one I'm going to do, whoa, this one I'm going to, oh, it's still green. Let me go back to my ink color here. Come on and make it purple. Okay, good. No, still green. All right, we're just going to have to do it green. So x is greater than 6. I'm now going to put an open circle here and go this way. Now, with an and statement, I need to find areas where both are true. And when I think about both, I really think about overlap or intersection. Where is it happening in both scenarios? Well, there's nothing happening down here, so I know this is no good. And if I look at this stretch from here to here, you can see that that's only true for x is greater than 3, but it is not true for x is greater than 6. 4 isn't greater than 6. 5 isn't greater than 6. It's not true. So I actually can eliminate this part too. So the only part that I really have that's true for both is what's left right here. If x is greater than 6, then it works for this and it works for this, because anything that's greater than 6 is also greater than 3. So my actual solution to x is greater than 3 and x is greater than 6 would look like this. It would be the open circle going this way, and the way I would write the answer to this is x is greater than 6. And so in interval notation, that would be 6 comma infinity. Set builder, you would know how to do it. So anyway, that's an interesting scenario. That's different than what we've seen. So when I have an and, I have to find the one that works for both. And things that are greater than 6 are also always greater than 3. So that is my answer. And we've got the number line here, and 3, and you can see where 6 is drawn. But we want the part that's the overlap. So now let's talk. This is almost the same. It's x is greater than 3, but the other option here is or x is greater than 6. We're not doing an and anymore. We're doing an or. So I'm going to do the helper graph again because it helps me visualize this. So if this is 3, 4, 5, 6. All right. So I'm going to try my colors again and see if it works. Okay, so x is greater than 3. That would be like this. All right. Now I really want a different color. Let me try red. Okay, so let's see if that worked. So for x is greater than 6, I'm going to do a helper graph like this. Okay? And that's for x is greater than 6. Now remember, we said with or is a union. It's including everything. It's a combination of this and this. As long as it works for either one, it works here. So in this case, I'm going to combine these two graphs. And if I combine everything that's in this one and this one, my answer becomes x is greater than 3. Because as long as x is greater than 3, that handles everything here, and it also handles everything, and x is greater than 6 is all the rest. So when I combine those, this is my answer. So when it was an or, it's an x is greater than 3, because that one represents the combination of x is greater than 3 and x is greater than 6, because everything in x is greater than 6 is already included in x is greater than 3. So if I'm trying to do the combination of those, this is my answer. I'm looking for what numbers work in one or the other, and you can see that in this example. Now, we got very different answers with and versus or. With and, we had to use x is greater than 6. That was the more limiting one because we had to make sure if it was true for both. And there are numbers that are greater than 3 that are not greater than 6. But or we can include everyone. X is greater than 3 and x is greater than 6. So this works for or and this works for and. And that was the difference, right? So if we look at these graphs, that's x is greater than 3, that's x is greater than 6. This whole graph represents the or, but just here represents the and because that's the only part of overlap. Okay, let's look at another scenario. What if x is less than negative 5 and x is greater than 5? Well, let's do those helper graphs again. Okay? So here's negative 5, here's 0, here's 5. If x is less than negative 5, I'm going to do a little helper graph up here that goes this way. And if x is greater than 5, I'm going to do a helper graph up here that goes this way. And if we all recall what and mean, it's overlap. It has to be true for both. I challenge you to find a place on this graph that is a solution for both this and this. Do you see any overlap? Is there anywhere where it works for both? Well, I definitely don't see anywhere. There is no overlap on this graph. So the answer to this is there's really no solution. And the way we write that when we're talking about sets is it's really the empty set. That's the symbol for the empty set. There's no solution because there is no number. I challenge you to think of a number that's less than negative 5 and greater than 5 at the same time. It just doesn't work. So there's no answer to this. But what if we just change one little word? And the little word we can change on this one is what if we said and versus or. Now I'm going to go back to this one. A number can't be both. Now if we said x is less than negative 5 or x is greater than 5, then this is the correct graph because I can include them both. It's either less than negative 5 or it's greater than 5. But there is no number that is less than negative 5 and greater than 5 at the same time. Okay, so we've already looked at that slide, so I'm going to keep going. Let's look at this example. What I'm going to suggest you do, because I have several more examples that I want to go through with you. So what I want you to do is in your notes, on your own, try to work out these next few examples. Work them out, struggle through them, because I think a lot of times it's going to make more sense to you if you've tried to work with it first before me showing you the answer. Then I want you to go and listen to recording number 2. I'm breaking this into 2 recordings. So this is recording 1. You can take a look at this and then work these problems and then come back, start at recording 2, and we'll start right here where we left off to finish up these problems. And hopefully you'll see that you got them right, or if you didn't, we'll work through what maybe you didn't understand.